Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Zaman. Today I will discuss nomenclature of some organic functional groups. In my previous lecture, I have discussed nomenclature of alkanes, cycloalkanes, alkenes, alkynes, aromatic compounds, alkyl halides, alcohols, amines, and carbonyl compounds including aldehydes and ketones. Today I will discuss nomenclature of carboxylic acid and their derivatives. Ester, amides, anhydrides, ester halides and nitriles will be discussed today. Nomenclature of organic compounds which possess sulfur and phosphorus will be discussed in this lecture. So at the end we will discuss nomenclature of some fused, bridgehead and Spiro compounds. So let's start with nomenclature of carboxylic acids. Organic compounds which possess COOH group, they are known as carboxylic acids. Carboxylic acids are named by selecting longest continuous chain having carboxy group at one end. The numbering starts from carboxy group and suffix in this case is oic acid. So it means E of alkane is replaced with oic acid in naming of carboxylic acid. Here you can see that we have 2-carbon carboxylic acid. It is known as ethanoic acid. Here we have 4 carbons. It is butanoic acid. So again we have 4 carbons, but one substituent methyl group is present here. Numbering start from this carbon 1, 2, 3, 4. Name of this compound is 3-methyl-butanoic acid. So it shows methyl group is present at position 3. Here we have 2-hydroxypropanoic acid because we have 3 carbon. Prop is the root 1, 2. At position 2 we have hydroxyl group. So it will be 2-hydroxypropanoic acid. Here we have unsaturation between carbon 2 and 3. Name of this compound is 2-butanoic acid. It shows that carbon-carbon double bond is present between carbon 2 and 3. So that's why it is 2-butanoic acid. So here we have benzene. Carboxylic acid group is attached with benzene. That's why it is referred as benzoic acid. We can also name this compound as benzene carboxylic acid. Here we have numbering start from this carbon 1, 2, 3, 4, 5. At position 4 we have phenyl ring. Name of this compound is 4-phenyl pentanoic acid. In this case we have 1, 2 carbon carboxylic acid. At position 2 we have hydroxy group and phenyl group. So name of this compound is 2-hydroxy 2-phenyl ethanoic acid. Some more examples is cyclohexane ring. Carboxylic acid group is attached with cyclohexane. Name of this molecule is cyclohexane carboxylic acid. So it will be cyclopentane carboxylic acid, but methyl group is present at cyclopentyl ring. So name of this compound is 1, 2, 3. Numbering start from this carbon. So methyl group is present at position 3. Name of this molecule is 3-methyl cyclopentane 1-carboxylic acid. So here we have some example in which 2 carboxylic acid groups are present in one molecule. So for example, if we have 2 carbon and both are carboxylic acid group, its common name is oxalic acid and its IUPAC name is ethane dioic acid. So here we have 3 carbon, that's why it is propane dioic acid. Here we have 4 carbon, so but is the root. Name of this molecule is butane dioic acid. So its common name is succinic acid and it is malonic acid. So here we have 2 carboxylic acid group which are present at benzene ring at 1,4 position. Name of this molecule is benzene 1,4-dicarboxylic acid. So here we have unsaturation between carbon 2 and 3. So this orientation is trans. So geometrical isomerism is possible in this molecule and this is trans. So name of this molecule is 2E-but. But is the root because 4 carbons. So 2E-but, 2-ene dioic acid. So here we have cis orientation. both carboxylic acid groups, they are present on same side of carbon-carbon double bond. So that's why it is cis. So name of this molecule is 2Z-but-2-ene-dioic acid. Common name of this acid is malic acid and it is fumaric acid. So let's start with carboxylic acid derivatives. So nomenclature of derivatives of carboxylic acid now will be discussed one by one. First, we start from esters. So esters are organic compounds which are formed by condensation of carboxylic acid with alcohol along with the removal of one water molecule. It shows that carboxylic acid, they contain two parts. One part is carboxylic acid part and other is alcohol part. So two parts, one is carboxylic acid and other is alcohol. For naming esters, first we have to mention alcohol part and then the second part or second word is for carboxylic acid. So alcohol part, it is mentioned as alkyl group like that. The ic acid suffix of carboxylic acid is replaced by ate in esters. First example, here you can see that 2 carbon alkyl group, it is ethyl ethanoate. So it shows that 2 carbon carboxylic acid is involved in this ester. So here we have 1, 2, 3, 4 carbon carboxylic acid and carbon-carbon double bond is present at position 3 because 1, 2, 3 and alcohol part alkyl group is ethyl. So name of this molecule is ethyl but-3-enoate. Here we have some more examples. Ethyl group. So ethyl benzoate, ester of benzoic acid. It will be 1, 2 chloro because this alkyl group is further substituted with Cl. Name of this molecule is 2-chloroethyl. This is alkyl part. 2-chloroethyl benzoate. And here we have substituted benzoic acid. Okay. So this substituted benzoic acid is involved in esterification with methanol. So alkyl part is methyl. Name of this molecule is methyl 2-hydroxy benzoate. So some more complicated alkyl group. Here we have 1, 2, 3, 4. So 2 methyl groups, they are present at butyl alkyl substitution. So name of this molecule is 2,3-dimethyl-butyl. Now alkyl part is actually butyl and that butyl, it contains 2 methyl groups. That's why it is 2,3-dimethyl-butyl. And now carboxylic acid part is also substituted. It is cyclopentyl ring and this ring is substituted with methyl. So 1, 2, 3 at 3 position. So it is 3-methyl 1-cyclopentane carboxylate. So here we have 1, 2, 3 propyl and this carboxylic acid, benzoic acid is substituted with amino group at position 4. Name of this molecule is propyl 4-amino benzoate. Okay. So here we have esters of dicarboxylic acid. So 2 alkyl groups, ethyl, it is diethyl propane dioate. Okay. So ester of this dicarboxylic acid, it is actually 3 carbon carboxylic acid, malonic acid. So ester of malonic acid, it is known as diethyl malonate. This is common name of this ester. So here we have ester of phthalic acid. So benzene 1,2-dicarboxylic acid. Okay. So here we have 2 ethyl groups. So name of this molecule is diethyl benzene 1,2-dicarboxylate. Or common name diethyl phthalate. So here we have unsaturation in cyclic ring. So this is the alkyl part, methyl 3-cyclopentene carboxylate. This 3 show that carbon-carbon double bond is present between carbon 3 and 4. So it will be 3-cyclopentene carboxylate. So next is amides. Amides are also carboxylic acid derivatives, and amides, they are formed by condensation of carboxylic acid with amines. Some other organic reactions like acid halides, they react with amine to gives us amides. are anhydrides, they react with the amines to gives us amides. So it means esters are also carboxylic acid derivatives like ester, and they consist of two parts. One is carboxylic acid, other one is amine. These are classified as primary, secondary and tertiary, and based upon the presence of alkyl or nitrogen substituted or unsubstituted. For example, if nitrogen is unsubstituted, nitrogen is attached with two hydrogens, then it is primary amide. In case when nitrogen is attached with one alkyl group and only one hydrogen is present, then it is secondary amide. And in case where two alkyl groups are present, it is tertiary amide. So for naming amides, the E of alkane is replaced by amide, or the oic acid of carboxylic acid is replaced by amide. For example, here we have two carbon, ethane, and just you replace E with amide. So the name of this molecule is ethane amide. So it will be again ethane amide, but in this case nitrogen is substituted with methyl group. So whenever nitrogen is substituted with any alkyl group or aryl group, then we must mention N-methyl or any alkyl group. So this shows that this alkyl group is attached with nitrogen. So name of this molecule is N-methyl ethane amide. It will be N-dimethyl methane amide because one carbon present in carboxylic acid part. So in other words, the common name is N-dimethyl formamide. Commonly it is abbreviated as DMF. So here some more example in which nitrogen is substituted with two alkyl groups. One is isopropyl, other one is methyl, and carboxylic acid part it contains 1, 2, 3, 4 carbon. Okay, but is the root. Name of this molecule is N-isopropyl N-methyl butanamide. So here is another complicated case. So here we have nitrogen which is attached with two carbon. So here we have N and diethyl. Okay. So here 1, 2, 3, 4, 5, 6, 7. So 7 hept is the root. But this alkyl root, it is further substituted with two double bonds and two methyl groups. So we must mention the position of these two methyl groups and these two carbon-carbon double bonds. So 1, 2, 3, 4, 5, 2, 5 methyl. Okay, and 3 and 6, these two carbons, they are substituted with double bonds. So name of this molecule is N-diethyl 2,5-dimethyl hep 3,6-dienamide. Okay. In other way, we can also name this molecule as N-diethyl 2,5-dimethyl 3,6-heptadienemide. So some more example. Here we have benzoic acid part. This is amine part. Nitrogen is substituted with methyl group. Name is N-methyl benzamide. So here we have nitrogen, but this nitrogen is substituted with phenyl. Okay. So this is not benzamide. The carboxylic acid part is this one. So here we have two carbon. It means ethanamide. So the name of this molecule is N-phenyl ethanamide. Commonly it is known as acetyl. So amides are those amides which are formed by condensation of carboxylic acid with aromatic amines or aniline. Now next class is ester halides. Ester halides, they are formed by the replacement of hydroxyl group of carboxylic acid with any halogens. Okay, so halogen X, it may be fluorine, chlorine, bromine and iodine. So the naming of these ester halides, it involves the oic acid of carboxylic acid is replaced with oil halide. Okay, for these compounds. For example, here we have two carbon, ethanol chloride. Okay, ethane from two carbon and oil chloride. Okay, so this is different as compared to alkyl halide. So don't mix this with alkyl halide, because if we have two carbon alkyl halide, it will be ethyl chloride. Okay. So here we have 1, 2, 3, 4 butanyl chloride. Here we have 1, 2, 3, 4 again butanyl, but carbon-carbon double bond is present. So that's why it will be butynyl chloride. And we must mention the position of this carbon-carbon double bond. So its name is but-3-enoyl chloride. or 3-butynyl chloride. So here we have double bond is present at position 2 and geometrical isomerism is possible in this molecule. Both the high priority groups, they are present on opposite side of carbon-carbon double bond. That's why it is trans isomer. So name of this molecule is 2-E-but-2-enoyl chloride. So here we have benzoic acid part and this is substituted to methyl group. So 1, 2, 3, 4, 5. 2 methyl groups are present at position 3 and 5. Name of this molecule is 3,5-dimethyl benzoyl chloride. Benzoyl chloride, C double bond OCl. If we have benzyl chloride, then it is CH2Cl. So there is a difference between benzyl chloride and benzoyl chloride. So here we have phenyl and 2-carbon ethanoyl chloride. So next is acid anhydrides. Carboxylic acid derivatives which are formed by joining two acyl groups directly with oxygen. So two acyl groups are attached with oxygen. The anhydride is a source of acyl group in chemical reaction. It means if you react this compound with some nucleophilic groups like amines or anidenes or phenols or alcohols, then they acylate these atoms, nitrogen or oxygen. So there are two types of anhydrides, which are formed by same carboxylic acid. They are known as symmetrical acid anhydrides. So in case of symmetrical acid anhydride, we name these molecules just by replacing word acid from carboxylic acid with anhydride. For example, here we have 2-carbon, so it means this anhydride is formed by ethanoic acid. So name of this molecule is ethanoic anhydride. Commonly it is known as acetic anhydride. So it will be 3-carbon propanoic anhydride. So here we have benzoic acid part, so benzoic anhydride. So in naming of symmetrical anhydride is simple and straightforward. Just we add the word anhydride before carboxylic acid part. Second type of anhydrides, they are mixed anhydride or unsymmetrical anhydride. So in case of mixed or unsymmetrical, two different carboxylic acids, they are involved in the formation of anhydride. For example, here we have 1, 2, 3 propanoic acid part. Here we have benzoic acid part. Name of this molecule is, just you mention the name of both carboxylic acid and at the end we add anhydride. It is benzoic propanoic anhydride. It will be 2-carbon, 1-carbon, so ethanoic, methanoic anhydride. It follows the alphabetical order. The cyclic anhydrides are also known, which are formed by dehydration of dicarboxylic acid. So this anhydride is formed by dehydration of malic acid. Okay? So it will be cis-butene dioic anhydride, known as malic anhydride. So it is butane, not butene. Here we have carbon-carbon double bond. That's why butene dioic. Here we have single bond. So butane dioic anhydride. Commonly it is known as succinic anhydride. So this anhydride is formed by dehydration of phthalic acid, benzene 1,2-dicarboxylic acid. That's why it is known as phthalic anhydride. So nitriles, they are also known as carboxylic acid derivative. Upon hydrolysis, they produce carboxylic acid. This group, when this is present on some compounds and if it is treated as a substituent, then it is known as cyano group. So here nitriles, 2-carbon ethane nitrile, just. So here we have acetonitrile, commonly it is known as acetonitrile, because when we hydrolyze this molecule, it gives us acetic acid. So here we have benzonitrile, because upon hydrolysis, this compound it produced benzoic acid. So here we have 4-carbon, 1, 2, 3, 4. So upon hydrolysis, it will gives us isobutyric acid. And according to IUPAC nomenclature, numbering short from this carbon 1, 2, 3. At position 2, we have methyl group. So name of this molecule is 2-methyl propane nitrile or isobutyronitride. If this group is present as the substituent in some molecule, then it is named as cyano group. So here we have 1, 2, 3, 4, 5. At position 5 we have cyano group. So this is ester. First we mentioned ethyl, 5 cyano, 2 hydroxy benzoate. So nomenclature of compounds which possess sulfur and phosphorus. We know that a large number of functional groups are organic compounds which we have discussed up to now. They contain carbon, nitrogen, oxygen and hydrogens, and some of them they possess some halogens. But there are many organic compounds which contains sulfur and phosphorus. So sulfur, it is present in group number 6 after oxygen, and phosphorus, it is present in group number 5 after nitrogen. So when we name these compounds, if organic compounds they contain sulfur, they are known as mercaptans. So if we have a such group, then we name these compounds as thiols. So 2 carbon, ethane, thiol. If we have 3 carbon, propane, and as such is present at position 1, so propane, 1 thiol. So here we have 1, 2, 3 carbons, and 1 methyl group is present at position 2. So name is 2 methyl, 1 propane, thiol. So here we have 1, 2, 3, 4, 5. Pen is the root, okay, and here we have carbon-carbon double bond at carbon 3 and 1 methyl group at position 2. So name of this molecule is 2 methyl, 3 pentene, 1 thiol. So you mention position of this carbon-carbon double bond also and this methyl. So if sulfur is attached to alkyl groups, then these are actually analogues of ethers, because if oxygen is present here, then compound is dimethyl ether. So when we name these compounds, we add word sulfide instead of ether. So name of this molecule is dimethyl sulfide. Here we have 2 ethyl groups, dimethyl sulfide. If we have different groups, for example methyl and ethyl, then it will be ethyl methyl sulfide. They are named in same manner as ether by replacing word ether with sulfide. Some more examples of organic compounds which contain this sulfur. So sulfur, because of the presence of d orbital, we know that sulfur and phosphorus, they are present in at second position of 6th and 5th group respectively. So they contain d orbitals. So because of the presence of d orbitals, they show variable valency. They can form 2 bonds and 4 bonds and 6 bonds. So such condition, they are not possible in case of oxygen, because oxygen is first element, sulfur is the second element of group 6. So if we have S double bond O linkage, then it is sulfoxide. If we have S double bond O linkage, then it is sulfone. If we have S double bond O and OH, SO3H, it is sulfonic acid. If we have sulfonate esters, if we have Cl here, then it is sulfonyl chloride, and sulfonamides, then here we have NH2. Okay, so let's name these molecules. It is dimethyl sulfoxide, it is dimethyl sulfone, because here we have sulfur is attached with 2 oxygen with double bonds. So again, ethyl methyl sulfone, so it is benzene sulfonic acid. So commonly it is known as tosyl chloride. Okay, so name is 4-methyl benzene sulfonyl chloride, or sometimes known as para-toluene sulfonyl chloride. This para-toluene sulfonyl chloride, this sulfur is electrophilic in nature, and nucleophilic groups like NH2 or OH, they attach at this sulfur and replace this good leading group Cl. So it is phenyl methane sulfonate. This is substituent phenyl, and this is methane sulfonate. So this is sulfonamide. So when Cl is replaced with NH2, this functional group is known as sulfonamides. Sulfonamides are well known for their antibacterial action. Okay, so this sulfonamide, for example, name of this molecule when 4-amino group is present, 4-amino benzene sulfonamide. This is first synthetic antibacterial. Okay, so for example, the 4-amino benzene sulfonamide, also known as sulfonylamide, is first synthetic antibacterial agent. The new derivatives of sulfonylamide have been synthesized, which are more active as compared to this parent sulfonylamide. So phosphorus containing compounds, they are known as derivatives or analogs of amines, because if nitrogen is present here, then it is trimethyl amine. So when we name these compounds, we call phosphines. So here we have 3 methyl groups, trimethyl phosphine. Here we have 3 phenyl, triphenyl phosphine. So this is Wittig reagent, which is used for the preparation of alkene. If this compound, which is known as Wittig reagent, react with carbonyl compounds, aldehyde and ketones, then we can prepare alkenes regiospecifically. Name of this molecule is methylene triphenyl phosphorate. So let's start with priority order of different functional groups. For example, if in the same molecule we have multiple functional groups, then we must assign the priority order so that we start numbering from the most priority group. For example, if we have carboxylic acid, it's their number 1, and then ester, and then acetylide, amide, aldehyde, nitrile, ketone, alcohol, amine, ether, halogen, and then nitro group. So for example, here we have a ketonic group, here we have bromo group, here we have cyano group or hydroxyl group. Then numbering starts from the carbon which is near to this ketone. It shows that this ketonic carbonyl group will give priority over bromo, cyano and hydroxyl. So name of this molecule is 4 bromo, 5 cyano, 6 hydroxy, hept is the root, 7 carbon, 6 hydroxy, heptane, 2 one. Okay, so here we have aldehyde group, here we have carbon-carbon double bond, here we have hydroxyl and then ketone group. So when we have double bond, ketone, hydroxyl and aldehyde, we give priority to this aldehyde group. So that's why numbering starts from this carbon, aldehyde carbon. It is number 1, 2, 3, 4, 5, 6. Hex is the root, and at position 2 we have double bond, position 3 we have hydroxy, and at 4 we have oxo. So name of this molecule is 3 hydroxy, 4 oxo, 2 hexenyl. So this 2, it shows the position of this carbon-carbon double bond. So this 2, carbon 2 is first carbon of this carbon-carbon double bond. So here we have substituted polysubstituted benzene. So when we have aldehyde group, cyano group and hydroxy group, we give priority to this aldehyde group. That's why numbering starts from this carbon. It is 1, 2, 3 and 4. Name of this molecule is 3 cyano, 4 hydroxy, benzaldehyde. Then we have amino group and hydroxyl group and carboxylic acid. We give top priority to this carboxylic acid group. Here we can see that this carboxylic acid is the top priority functional group. So its name is 3 amino, 4 hydroxy, benzoic acid. Some more examples of organic compounds which possess multiple functional groups so that we can assign the priority order to these compounds. It is ester, ketonic carbonyl and amino group. So numbering starts from ester carbonyl carbon. 1, 2, 3, 4, 5, 6. Hex is the root. So this alcohol part is alkyl, ethyl, 2 carbon. So it is ethyl. At position 3 we have amino group, 3 amino, and at position 4 we have carbonyl, oxo, 4 oxo, hexanoate. This 8 shows the ester functionality. Here we have amide. So numbering starts from amide carbonyl carbon. 1, 2, 3, 4, 5, 6. So hex is the root and methyl group is present at nitrogen. So at position 3 we have hydroxy group and at 4 we have ethyl group. Name of this molecule is N-methyl, 4-ethyl, 3-hydroxyhexane amide. Okay, so this is 6 carbon hexane amide. Here we have nitriles. Numbering starts from this carbon. 1, 2, 3, 4. At position 3 we have oxo, and at position 2 we have phenyl group. But this phenyl is further substituted at position 3. 1, 2, 3. So its name is 2,3-chlorophenyl. Okay, it shows that phenyl is present at position 2 and this phenyl is further substituted with chloro at position 3. It is 2,3-chlorophenyl, 3-oxo-butane nitrile. Okay, 4 carbon. Here we have another example of ester. So when ester and aldehyde, they are present in the same molecule, we give priority to ester. This is alkyl part, ethyl, 3-methyl, 4-oxo-butanoate. So let's start with nomenclature of some fused ring, bridged and Spiro compounds. Fused ring, when two rings they are fused with each other, so both these rings they share these two carbon. So here name of this molecule is bicyclo. It shows that two cyclic rings are present. And 440, 4 for these 4 carbons, 4 for these 4 carbons. Okay, 440 means between these bridge we don't have any bridge carbon. So this is fusing known as bicyclo 440 decane. Decane show that 10 carbons are present in this molecule. Commonly it is known as decaene. So decaene may exist in two different forms, cis and trans. Okay, so this is trans bicyclo 440 decane. As you can see that this hydrogen is present at axial position. Okay, and this is equatorial position. And here we have this carbon or this hydrogen axial, and this carbon is present at equatorial position. But in case of cis, this hydrogen is present at equatorial position, and this carbon is at axial position. So this is trans bicyclo 440 decane, and it is cis bicyclo 44. Again we have 4 carbon here and 4 carbon 1, 2, 3, 4. 440 decane. So again we have bicyclo 330 octane. Total 8 carbons are present. 1, 2, 3, 4, 5, 6, 7, 8 octane. And 3 carbons are present here and 3 here. And here we have no any carbon in between these two carbons. But in this case we have a bridge, 1 carbon. So name of this molecule is bicyclo 221. This one shows that a bridge is present, 1 carbon is present between these two carbons. Okay, so it is bicyclo 221 heptane. Total 7 carbons are present in this system. So here we have bicyclo 222 octane. Total 8 carbons are present in this structure, and 2 carbons are present at bridge head. Okay, so name of this molecule is bicyclo 222 octane. So some more examples. Here we have 3 carbons and 2 carbons, and 2 carbons are present at bridge head. It is bicyclo 322 no name. It shows that 9 carbons are present in this ring system. So it is bicyclo 211 2, and here we have only 1. So 2 for these 2 carbon, 1 for this carbon, and 1 for this bridge head carbon. So it is bicyclo 211 hexane. 6 carbons are present in this ring system. Spiro compounds are those in which 1 carbon is shared between these 2 carbons. So these 3 systems they contain Spiro structures. So name of this molecule is Spiro 2,2-pentane. So this Spiro for this ring system, and 2 show number of these carbons in both these rings, and pentane total 5 carbons are present here. In this case Spiro 4, 5, 1, 2, 3, 4, and 1, 2, 3, 4, 5. So it is Spiro 4, 5 decane. So it is Spiro 2, 3 hexane. Spiro just because it shows the class of compound, and 2 for these 2 carbons, and 3 for these 3 carbons, and hexane show total 6 carbons. So this is all about nomenclature of organic compounds. So in nomenclature of organic compounds we have discussed naming of all the functional groups and IUPAC rules which are followed for naming of these organic compounds. So in my upcoming lecture I will discuss the methods of the preparation of these organic compounds and chemical reactions of these functional groups. So one by one I will discuss different synthetic and industrial or laboratory methods which are used for the preparation of these functional groups, and also I will discuss the functional group interconversion, how one functional group is converted into another one. Thank you very much.